Okay, so I'm going to be showing you how to convert a context-free grammar, CFG, into a context-free grammar that is in Chomsky normal form, so a CFG in CNF. So we're going to be using a little bit more of a, robust example, I guess, as opposed to something simple like, S goes to A, and then, something, okay, so anyway, let's make a palindrome, a regular CFG for palindrome, where you have the alphabet is just A and B. And this is going to accept the empty string, which is important because to demonstrate the process of converting to Chomsky normal form. But it will also accept odd palindromes, i.e. just the letter A, and even ones, or AA. And there can be different ones. For example, BAB is an odd one, but also BAAB. But let's go ahead and get started. So start state, call this one, goes to ASA, because you can either start with a palindrome of A, but then you have to start filling in things here in the middle. And alternatively, then we'll also have S goes to BSB, because you don't have to start the palindrome with A. You can start with B, but if you're going to do that, you definitely have to make sure that it's going to read backwards the same way with this S. So then also S can go S can go to A, and S can also go to B. Furthermore, let's see. Okay, and then so we would have S goes to lambda, which is the empty string character. And so for example, let's go ahead and make some palindromes. So A is super easy to derive, just do S goes to A by rule 3. B, let's do S goes to B by rule 4. Empty, S goes to lambda empty by rule 5. A, B, A, B, A. So this is going to be, what? S goes to ASA, and then S goes to A by rule 3. Oh, wait. Anyways, it's not important. This is the palindrome for a, this is a CFG for palindrome. But obviously this is not in Chomsky normal form. For example, this is a non-terminal going to, for one thing, a mix of terminals and non-terminals, but also, it's not length 2. This is acceptable. This is a, this is in Chomsky normal form right here, because it's a non-terminal going to a terminal. But this is not acceptable, this is not acceptable, and this is also not acceptable because there are no null productions in Chomsky normal form. So something like this where it just goes to null is not acceptable. So let's start off with process 1. So in process 1, you identify the nullable productions, and you just get rid of them. So we do have to then consider what we end up losing and removing this. There's only one null production here. It's this one. But if we remove that, for example, consider what happens when we try to do something like BSB. Well, one thing, you can't take this at all because there's still non-terminal, but we lose the ability to just do B lambda B equals BB. So this would give us a problem with trying to generate even palindromes. So we've identified this, and in the next step of this part 1 has 3 steps. Part 2 would be to do something of the form where we consider each production that has the thing in there, and to do something of the form like AX, B, Y, C, Z, D. But that doesn't really apply to this one here, so what we simply do is just kind of ignore this one. So let's go ahead and actually just go ahead and rewrite this in orange, our productions. And mind you, this won't be exactly palindrome by definition of, Chomsky normal form. We end up getting palindrome minus the empty string. But we now consider step 3, which would be to simply delete all the nullable non-terminals, which would be this. So here we just simply don't have it anymore. And then step 2 is to remove unit productions, and we don't actually have any unit productions here. A unit production is something of the form x goes to y, or y goes to z. And if we have something of the form z goes to lambda, then we can consider all 3 of these nullable non-terminals, because you could follow the path x goes to y, goes to z, goes to lambda. But in the case of this one right here, we actually don't have any, so we can actually just entirely skip over step 2. But step 3 has to deal with separating terminals and non-terminals. So as I mentioned earlier, this is a problem because we have the terminal A, but also the non-terminal S, and that's not allowed in Chomsky normal form. So what we do now is actually we just make every single terminal a non-terminal. So now we'll have something of the form like this: capital A, SA, capital B, SV, and then these are actually totally okay. So the modifications we made were here, and this is actually, now we're done with this one, so we can move on to step 4. And step 4 is to ensure that the right hand side is limited to exactly 2 non-terminals if there's non-terminals. So this is the one, these are the ones that are in violation of this. Again, these have always been in Chomsky normal form, but this is not acceptable. So what we do is we actually go ahead and just kind of like break them up into 2 separate ones. So what we'll do here is I'll actually have to separate this. So we can make a 3-letter character like this by just kind of splitting it up into 2. So we can make this actually be S1, and then simply have S1 go to SA. And so if we follow, you know, S goes to AS1 by rule 1, and then by rule 2, S1 goes to SA. Then it's the same thing, we still get ASA at the end as if we just did S goes to ASA with the normal CFG. But again, that's not allowed with Chomsky normal form, so we end up doing it this way instead, where we have, we broke it up into like prefixes. But now we would have to do the same thing for this one right here with the BSB. So obviously that's not allowed, that's 3 non-terminals instead of 1. So again, we'll just kind of erase this B and make this S2, and then have S2 go to SB. And now this is the exact same thing. We can go ahead and do S goes to BS2 and have S2 go to SB, which gives us BSB. And then from here, we can really just kind of do whatever we want. This is actually the palindrome without lambda, you know, the CFG for it in a Chomsky normal form. Oops, except we did fail to consider a few things, actually. We do have to add a couple more rules, because this won't allow us to make, this is going to give us a problem with making even palindromes, but also B and S never go to anything. So we will add rules here. Add rule 7 and have A go to little a, because that's obviously the point of A. And then the non-terminal B will go to little b. But also now we have to have A goes to AA. Well, S goes to AA, actually. And then 10, we have to have S go to BB. And so, for example, this is so we can get things like this palindrome and this palindrome. And that's because without this, the only thing you could do was make just, you know, 1A, but that's not this. Or we could do S goes to AS1, which goes to ASA. And then you could turn this into A and you could turn this into A, but now your only options are to turn this S into A or B, or to make a bigger palindrome, because again, there is no there's no nullable non-terminal productions in Chomsky normal form, so this accounts for our inability to make even palindromes. But now this is the CFG in CNF for palindrome.